Physics students, good afternoon. I'm Mr. Shuby here. Today in this video, we're going to be looking at group problem number 2A, which covers over some concepts involving one-dimensional kinematics. Now, you can access the group problem on Canvas just under our page for Unit 2. It is there if you need access to it. And here we're going to be working through the parts of this group problem. I'm not going to read through the entire context of the problem. Hopefully you've had a chance to look that up, or you have a copy of it, or can access that through Canvas. Essentially, we're looking at two different objects, both traveling in the same direction. So we'll go ahead and start. Part A is going to ask us to draw a picture. Essentially here we have two objects moving towards the same final destination. We have one of them is Avatar Aang and Appa, if you're familiar with the context of the cartoon. Right? It's not just a cartoon, much more than that, but we'll call it that. Right? So we've got Aang and his vehicle of travel, which is Appa, a sky bison, if you will, traveling to a certain destination. And then we have Zuko, another character in our scenario, also traveling to the same destination, which is a temple, if you will. It doesn't have to be a perfect picture, but we've got two objects traveling to the same destination. We're trying to figure out if Aang, who's our main character, can get to the temple in time, talk with his friends, and have enough time to do so before Zuko, our villain here, arrives. So part B is going to ask us to list out our variables. What do we know about the problem statement? Now, we have 5 variables when we deal with kinematics. Delta x, our displacement, how far we travel. V0 or V0, our initial velocity. V1, our final velocity, acceleration A, and time. Now in this scenario, we know several things. We know that Aang has to travel 108 kilometers, that's part of our background. But we want to make sure that we are in the proper SI units, so that would be 108,000 meters, multiplied by 1,000. We are told that Aang and his vehicle, right, the animal he's riding on, Appa, travel at a constant velocity of 16 meters per second. We are going to assume that he starts this journey and continues that journey at the same rate, 16 meters per second. So that will be his initial and final velocity, meaning he's always traveling at that velocity. Now, realistically, it would take Aang a little bit of time to get up to speed. But that's going to be such a small time, we're going to assume it instantaneously happens. Which means, in this scenario, we don't have any acceleration. That is 0 meters per second squared. And what we're trying to find out here is, what's going on with our time? How long does it take him to arrive? So part B is really just asking us, find the variables. Identify what we know. Part C is going to ask us to use those variables to solve for time. Now in our scenario, we know a lot of things, but we don't know time, which is what we want to find. Acceleration is really the value that we don't care much about here. So if we look at our kinematic equation sheet, look at where acceleration does not show up. That would be equation 4, something like this. Delta x is equal to 1/2 v0 plus v1 multiplied by time. So now that we've identified our equation, we can plug in the variables appropriately. Delta x is 108,000 meters, is equal to 1/2 V0 or V0 and V1 are both 16. Plus 16 multiplied by time. Now if I add the two 16 values together inside of our parentheses, that gives us 32 multiplied by 1/2, and that gets us back down to 16. So we can simplify our expression down to 108,000 meters is equal to 16, that's a velocity value, meters per second, multiplied by time. Now we're interested in figuring out the time, so I'm just going to divide both sides of our equation by 16. So 108,000 divided by 16 gives us a time value of 6,750 seconds. That is how much time it would take us to arrive, right? Or it would take Aang to arrive, better yet. Now, the reason we know our time value is in seconds is because of the units that are in our equation. Distances or displacements in meters, velocities meters per second. So the resulting answer we should have for time should be in seconds. Now, we'll scroll over to the other parts of our problem. So now we've solved B and C. D tells us, at this point, we know how long the journey will take. That is a time of 6,750 seconds. From there, we are told that it will take an hour to consult with his friends. A long conversation, if you will. Now, because we have a time value in seconds, we need to add not just 1 hour, but a value of seconds. So an hour, 1 hour, 1 hour is equivalent to 60 minutes. And 60 minutes, 1 minute is equivalent to 60 seconds. So 60 multiplied by 60 gives us a value of 3,600. So 1 hour is equal to 3,600 seconds. So when we add these values together, we get a total of 10,350 seconds. So now we know the total time for Aang to get all the way to the temple and consult with his friends. So now we'll move down to part E. Part E is telling us that for Zuko doesn't travel at the same speed for the entire journey. Zuko starts at rest and then gradually gets up to speed. So here's what we know about Zuko. Just as he is getting up to speed, we don't actually know how far he travels just in getting up to speed, right? We know how far he travels for the duration of his whole journey, but not that little part of him getting up to speed. We are told that in getting up to speed, Zuko starts at rest, but we want to know how fast does he end up going once he reaches his top speed. The problem does tell us we accelerate at a rate of 2.5 meters per second squared for a time of 4 seconds. So in this scenario, delta x is what we don't know. Remember, just because we know a delta x value doesn't mean it's this specific delta x value. If you plug in 108,000 meters here, that value does not correspond to our other values. They don't all fit the same scenario. We need to figure out what is our top speed. So delta x in this scenario, we don't know, we don't care about. So we look at our kinematic equation sheet. That should lead us to equation 1. V1 is equal to V0 plus acceleration times time. Now V1, what we want to know, we don't know, so we'll just leave that as V1. V0, our initial velocity is 0. So 0 plus our acceleration, 2.5 meters per second squared, times our time, 4 seconds. So 2.5 times 4 gives us 10. 10 plus 0 leaves us at 10 meters per second. That is the top speed we are looking for with Zuko. Now, once we know that top speed, we're going to assume he travels the rest of his journey at that speed. The problem says the distance that he travels, Zuko, while getting up to speed is so small, we're going to pretty much ignore it. We're going to assume, for the most part, he's traveling the entire journey at this velocity of 10 meters per second. So now, we'll list out the variables that we know. Now, we're looking at Zuko traveling the entire displacement from his starting location out to the temple. We're now going to assume he is at 10 meters per second, and he will remain the entire journey at 10 meters per second. Now you're probably thinking, why did I call that V0 my initial velocity 10? Right? Wasn't our initial velocity just 0? Remember, there are two situations here. Zuko getting up to speed, and then Zuko moving at that same constant speed, right? As it says on your kinematic equation sheet, we can't use we have to have the same acceleration when we're using a kinematic equation. The first equation, we have an acceleration for Zuko, getting up to speed. This second equation, we don't have an acceleration for Zuko, right? He's not accelerating, he's staying at that same top speed. So our acceleration here would be 0 meters per second squared. And our time here is, well, we don't know. We want to figure out how long does it take Zuko to get to the temple and compare that back to what we know for Aang. So, here we go. Acceleration, that's not really a focal point for this part of our scenario because we're not accelerating here. We want to find time. So, acceleration not being a factor, that's going to be equation 4 again. Delta x equals 1/2 V0 plus V1 multiplied by time. Our delta x here, 108,000 meters, is equal to 1/2 multiplied by 10 meters per second plus 10 meters per second multiplied by time. Okay, so basic order of operations, we'll look at our parentheses first. 10 and 10 added together gives us 20. Multiplied by 1/2, divide by 2. So 20 times 1/2 gets us back down to 10. So next, our equation will be simplified down to this. 108,000 meters is equal to 10 meters per second multiplied by time. Now from here, hopefully we should see to get time by itself, we'll divide by 10 on both sides of our equation. So 10 over 10 simplifies down to 1. Time for Zuko will now be 108,000 over 10, which will be 10,800 seconds. So this is the time it will take Zuko to travel to the temple. If we come back and compare that to what we know for Aang, it takes Aang 10,350 seconds to get to the temple and have the hour to consult with his friends. So if we come back to the beginning of our question, right, which was, does Aang have enough time, right? Does he get there, consult with his friends before Zuko does? So yes, Aang is good, Aang is safe. And why? We back that up. What's our reasoning? Well, his time, 10,350 seconds, is less than 10,800 seconds. Aang gets there and consults with his friends in less time than it takes Zuko to make the journey. So again here, we're looking at applying what we know about kinematics, the study of motion, to a real world or cartoon world scenario. Okay, but remember the process that we're looking at. Listing out our variables, identifying our equation, and then plugging our variables into our equation appropriately and solving for what we want to know. Right? Our final answer here is a yes or no question. But our evidence for that answer is what we solved using our kinematic equations. Okay? Again, there is a key for this problem on Canvas, so you have access to the answers. If you do have questions,